Hello, today I am going to share with you about the comparison instruction for equal, not equal, must equal instructions. So let me create a new file so that I can explain further to you. Click File and then click New. Okay, select any option here. Make sure driver is Emily 500. Okay, let me make it bigger and then maybe insert a run. Okay, let me insert necessary instruction here. I insert this virtual switch and then insert this branch and then insert this virtual output coil. Okay, then I click this compare tab. This compare tab consists of all the comparison instructions, include the limit test, must comparison for equal or must equal, equal instructions, not equal instructions, less than, etc. Okay, let me insert this equal instructions to here as well as not equal instructions to here. Okay, so let me assign address. So I will assign binary address. Again, if you are not sure, you can refer to data file. The binary address start from B3. So B3 column word 0 slash bit 0. Okay, so this one I will assign digital output column 0. Okay, word 0. Then column slot 0 slash bit 0. Okay, so and then for this I will copy the virtual switcher. This one I will copy the virtual switch, the virtual output here. This one I will change to bit 1, and then this one I will change to bit 1. Alright, and then I will choose must comparison for equal. Okay, so for this we need to assign the address, and the address should be the word address. So what do I mean by this word address? Address, of course, is address. Word consists of 16 bits, right? So why? Because the value we compare can be small or big or very large value, so it should be in the form of word, right? Okay, this time you can use an integer or floating point data files. So for this one I will use the integer. So integer start from n7, so the address is integer n7 column. Okay, I use word 0. All right, okay, maybe I copy this. Okay, this one I use word 1. Okay, then note that this source A must be the address. Source B can be either address or constant value. All right, so this one I will use 2. Okay, this one I will use 3. Okay, this one 4, and then this one 5, and then this one 6. All right, okay, so maybe I shift this virtual switch to here, and then I copy another one to here. So this one I will change to 1. This one, this bit I will change to 2. All right, okay, and then I compile the file by clicking here and here to make sure there's no error. Then I click here, click the download. Then you can save the file in your computer hard disk to whatever directory folder you prefer. So this one I will use this file name. Okay, then I click here to select run, to run the program. Okay, so this, let me pull this program to here, and then I click integer here. so that it will be easier to see. All right. Okay, let me set to binary format. You can set to binary or decimal format. It's up to you. All right. So this one. Okay, so for equal instructions, what happened is it will compare the source A value with the source B value. If it is equal, then this will be energized, right? And then it will allow the virtual power to flow through the rungs to energize the output coil, virtual output coil. As for not equal comparison instruction, it will compare the source A value with the source B value, whether it is not equal. If it is indeed not equal, then this instruction will be energized, and the virtual power can flow through here, through this rung, to energize this virtual output coil. Similarly, in other words, if this value and this value is not equal, meaning different values, it will be energized. But if it's equal value, it will not be energized. So it's just opposite to these equal instructions. Okay, for these must equal instructions, it works slightly different from the equal instructions because it got the word must. So what do we mean by must? So for me, my own interpretation is the must is just like a activation deactivation function. Okay, what do I mean by this is, let's say this, you can see the must integer is n7 column 5. This one n7 column 5. So if I set the bit, okay, from any bit here, if I set any bit here from 0 to 1, so it will be activated. And then you will compare the source A bit with the source with the comparison reference bit here. Okay, this source and this compare. So you can treat compare like a source B or the reference value. Treat this source as a source A. So it, with the must condition set, it will compare the source A with the comparison or reference value. Okay, so for example, if let's say I set this bit from 0 to 1, it will compare this source bit with the reference bit here. Okay, if this one's 0, if this one is 1 and the source value is 0 and the reference value is 0, so this source value and reference value will be the same. So this will be energized, right? If let's say it is 0, okay, the must be is 0 here. It means it will be deactivated or ignore. So it will not compare. Okay, so let me demo so that it will be easier to understand. So let's say I toggle bit here and the n70 here, I set the value here and the value here is the same because the both values are same. So it will be energized and the virtual power can energize the virtual output coil. Right? Let's say I set the value here to 10. So what happened? It will be de-energized, right? Because the value is different. Okay, so this is a binary, so I change the radix to decimal, so it will be easier for me to change the value. Let's say I set to 15. Okay, it will be different. If I set this one n71, I set to 15 also. You can see the n70 value and n71 value corresponds to this value. And what happened, it compared to source A and source B value. Both value are same, right? So this instruction will be energized. And then what happened is the virtual power can flow through this rung to energize the virtual output coil, right? Okay. So let's say I de-energize this switch. Okay. For this N72, let me put some value. Let's say I put 23. Okay, so if I manually toggle it, what happened? So it will compare the source A value, which is 23, with source B value, which is 0. Okay, let me set some value. Maybe I set it 9. Alright, So it will compare these two values and see whether they are not equal. Obviously, these two values are not equal. So what happened? It will be energized. So the virtual power can flow through here and then do this run, and then it will energize the virtual output coil, right? So how about if I set both same value? This condition will no longer true, right? So it will be de-energized. So the virtual power unable to flow through this run to energize the virtual output coil. You can compare not only positive but also negative value. Okay, let's say I said negative 20. So both value is different, right? So both value is not equal, and then this instruction will be energized. So if I set this to negative 20, so this condition is no longer true because both value are same, right? So this will be the energized. Okay, let me normalize this virtual switch. So how about this? This will be slightly complicated. Let me set the radix to binary, and then let me focus on N74, which is a source, N75, which is a mask, and N76, which is the compare or the reference value here. Okay, let's say this mask can be in the binary form or hexadecimal form. So if you want to have a easier understanding, try to say in the hexadecimal format. For hexadecimal format, you group four binary bit into one group. Like this one, 1, 2, 3, 4, first group, 1, 2, 3, 4, second group, etc. Let's say I toggle it. So what happened is the bit here, you see N75, which is a mask bit here, is 0. 0 means it will be deactivated or ignore. So it will not compare, and then it will turn on just like that. Alright, so you can see the virtual power will energize this virtual coil. How about if I set this value to 1? Alright, this will be 1. So you can see it's still energized, right? The virtual output coil. How about I set this to 1? Okay, so this value is 4. You can see 4 here. It's still energized. Why? Because the bit here is still 0. It will be 0 means it will ignore. Ignore what? Ignore the must equal comparison functions. Right? So that means you just turn on like that because it's 0. How about if I turn this one to 1? If I set this bit from 0 to 1, what happened is this must equal comparison will be activated, and then it will compare the bit here with the bit here. This bit is a source bit. Okay, this bit is a compare or reference bit. So this bit is 0 compared to 1, which is not equal, right? So what happened? It will be de-energized. If let's say I set this to 1, correct? So it compare this source bit with the reference bit here. So 1 equal to 1. What happened? This will be energized, and the virtual power can flow through the run to energize the virtual output switch. If I set these bits to 1, 1, 1 here, and then maybe this bit to 1, and then I put the 1 here. So what happened is this 1 for the mask integer bit will be activated for mask equal function comparison, right? So it will compare this source bit with this reference bit, 1 and 1 equal. Okay, the 0 bit will be ignored, and then this is activated because it's a bit 1. You compare this and this whether it's equal, and then you can see both are equal. So these instructions will be energized. If I set this to 0, what happened? It will be de-energized. Why? Because its source and reference bit is different. How about if I set to 0? This bit and this bit now is equal, right? So you can see this and this equal and this equal, so this instruction will be energized, and then the virtual power can flow through this rung and energize the virtual output coil. Okay, so that's it. Thank you.